Okay, this is the second video. In this video, we're going to actually walk through several problems. You should have looked at the list of 4 steps that I generally follow. There are exceptions. There are certain problems and more complex problems which you have to kind of think about a couple of different things that could happen. But this is the foundation. Step 1, what do you have to do? Step 2, where are they coming from? Step 3, start counting, ask the question, can something be put back? That's on a group basis. Step 4, do you care about the order? Does the order make a difference? If it does, you're done. If it doesn't, you're going to be dividing. Okay? So, no order, you're dividing. And again, this is a group by group decision. So, let's just get started here. Example 1, if you've taken my lecture class, we've walked through that. We've been to the fair. Well, you got to sit through this again. All right? Anyway, I'm headed over to the parish fair. And I plan on entering one of my 7 blue ribbon nutria into the competition. How many ways can I choose one of my nutria to take? So, very simple problem. You probably know the answer, but I'm going to walk you through the routine. The first thing I need to do is I need to know what I need to do. I need to pick a nutria to take on or take to the fair, right? That's going to come from a group that consists of 7. So, I start counting. 7 ways to pick it. I'm only picking 1. Don't care about replacement. Step 4, is there order? I'm only picking 1. How can there be order when you're only choosing one thing, right? So, answer is 7. Step 2. Let me just mention, you can always stop the video, work the problem, watch the video, right? So, read the problem, stop the video, read the problem, work the problem, and watch the video. I like to usually mention that at the beginning, but failed to do that. Just remember that. Anyway, it's not edited. Who knows what's going to happen here, right? Okay, number 2. I found out this year the parish fair will have a crawfish competition. So now I plan on entering one of my 7 blue ribbon nutria into the competition and also one of my 27 blue ribbon crawfish. How many ways can I choose a nutria and a crawfish to take? So, step 1 is what do you have to do? I need to pick a nutria. I need to pick a crawfish. That's what I need to do, right? Where are they coming from? Well, the nutria are coming from 7 nutria. The crawfish are coming from a different group, 27 crawfish. Okay? Like I said, I like to draw boxes up here because it identifies different groups. 1, and second, I can put how many are available to me. All right, so we've done step 2. Step 3, I start selecting. I go to pick a nutria. There are 7. I'm only picking 1. There's no concern about replacement. Step 2, I'm picking a crawfish. There are 27 crawfish. Okay? Again, don't care about replacement. Now, do we have order? Order is group specific. Okay? So here's one group, and here's another group. I'm only picking one thing from each group. In a group, when you pick one thing, there's no order, right? So I'm done. The answer to this problem is 7 times 27. This is essentially just the fundamental counting principle problem, okay? So it might have been obvious, but I'm trying to lay the foundation of the process I go through in counting. Let's move on to question number 3, or example number 3. Again, you can stop the video. I get to the fair. Now, there's a beauty contest going on. I plan on entering one of my 7 blue ribbon nutria, one of my 27 crawfish, one of my 8 octuplets. How many ways can I choose a nutria, a crawfish, and a beautiful child to enter into the competition? Well, step 1. What I need to do? Pick a nutria. Pick a crawfish. Pick a beautiful child. Where are they coming from? Well, the nutria are coming from 7. The crawfish are coming from 27. And the beautiful child is coming from 8. So I got 3 different groups here. Pick a nutria, 7 ways. Pick a crawfish, 27 ways. Pick a beautiful child, 8 ways. Again, in none of the selections do I care about replacement. Why? Because again, replacement and order is group specific. I'm only picking one from each group. So I don't have to worry about replacement or order. So if you do the math, again, I'm going to leave that up to you. That would be your answer. Problem number 4. Stop the video. Rewind the video. You got total control here. I'm still at the fair, and I get selected to judge the shrimp Creole competition. And of course I say yes. Now I have to select the tastiest, the hottest, and the most unique shrimp Creole. If there are 12 entries, how many possible ways can I do this? Okay? So, what do I need to do? I'm judging a shrimp Creole contest. I'm going to have to select the tastiest shrimp Creole, the hottest shrimp Creole, and the most unique shrimp Creole. That's what I need to do. Where are they coming from? There are 12 entries. Step 3, I start to pick. When I pick the tastiest, there are 12 choices. Now, I have to ask myself, can I put it back? Well, think about it. The way this is worded, if I have the tastiest, it is possible it still could be the hottest. It could be the most unique. There's nothing here that would indicate that somebody's shrimp Creole could not be the tastiest, the hottest, and the most unique of all of them. So, I'm saying that once I pick the tastiest, you can go back and sit down because you could be picked to be the hottest. Go back because you could be picked to be the most unique. So I get 12 times 12 times 12. Now, step 4, is there order to it? Yes, there is. If you get picked first, you're the tastiest. If you get picked second, you're the hottest. If there is order, you do not divide. So, I don't have to divide. This product here is the answer. Moving on to number 5, and we'll leave it here. So read number 5, stop the video. Things are going on at the fair. People are getting upset because we're told now that we're only supposed to pick one person can only get one of the particular classifications here. I'm told to select a different entry for each of the 3 classes. Okay? So, let's get started. Whoa, we also find out that there are only 9 entries. But I'll find that out in a little while here, okay? Because I got an order here. The first thing I should be considering, what do I need to do? Well, I'm told I got to pick the tastiest. I need to pick the hottest. I need to pick the most unique. Where are they coming from? Hey, now that's when I'm worried about this. You know, before there were 12, but now there's 9. I don't really care what. 3 people went home. The thing is, now's the time to ask that question. Where are they coming from? There are 9 entries. Step 3, I start to pick. When I pick the tastiest, I have 9 choices. This is when I'm picking from the same group. And when I'm picking from the same group, I ask about replacement. So, can I put them back? No, we can't. We're told we can't put them back. They have to be different. So, now my number is going to go down. 9, 8, 7. Step 4. Do we have order? Yes, we do. You pick first your tastiest. You pick second your hottest. I said something different here. So there's no division. Do your math. That's your answer. Moving on. Well, the shrimp Creole competition is over, and the mayor texts me, and he tells me to bring him the 3 best Creoles. And remember, there are 9 entries because 3 people went home. All right, so the mayor's asking me to do something. I'm going to do something. I'm going to do whatever the mayor tells me, right? So, he's the one providing me my free parking. So I'm not going to mess with the mayor. But anyway, The mayor wants me to do what? Pick the 3 best Creoles. So I need to pick a best Creole, another best Creole, another best Creole. Step 1, what do you need to do? Step 2, where are they coming from? They're coming from the 9 entries, right? When I go pick the first best Creole, how many choices? 9. Can I put it back? No, I can't put it back. He wants the 3 best Creoles. So if I show up with 2, he's going to be upset. So if I want the 3 best Creoles, I can't put something back, and my numbers are going to go down. So I get 9, 8, 7. Step 4. Is there order here? Well, think about it. If you're picked first, you're one of the 3 best Creoles. If you're picked second, you're one of the 3 best Creoles. I said the same thing. It doesn't matter when you get picked. In other words, there's no order, and when there's no order, you divide by a factorial. The factorial is how many did you pick? I picked 3, so 3, 2, 1. Do your math? That's your answer. Okay? Okay, I'll let you pause and you can read the material right here. I'm going to jump right to number 7. We're back at the fair, and I can order a king cake. I have one choice of each of the following: 4 different doughs, 4 different fillings, 2 types of icings. How many possible king cakes are there? So, step 1. If I'm going to choose a king cake, and I'll say I have to choose one of each, okay? I need to pick the dough. I need to pick a filling. I need to pick an icing. Okay? Now I have to pick one of each, okay? That shouldn't really be part of the problem, honestly, because if I didn't have to pick a dough, I'd actually have 5 choices. No dough. I don't know who's going to make a king cake without dough, but anyway. But that is significant. All right, so this is what I need to do. Pick a dough, a filling, an icing. Where are they coming from? Well, the dough has to come from 4 doughs, the filling, 4 fillings, and the icing, 2 icings. Start picking. Well, again, this is pretty straightforward, so I'm going to fly through it. I'm only picking 1 item from each group, so I don't care about replacement. I'm only picking 1 item from each group. I don't care about order. Okay? Remember, you may want to rearrange these things and say there's an order here, but order is group specific. Okay? And since I'm picking from different groups here, okay, I don't care about, the order is not to be considered. So I am done with the problem. You multiply, hey, you know what, I'll do this one for you. 32. Okay? Alright, so again, remember when you're talking order replacement, it is group specific. So once I finish doing my numbers here, I am done. Now we left the fair, about time. Let's go home, work some math problems, and eat some king cake. Our next example, we have a password. It consists of 2 letters followed by 5 digits. How many different passwords are possible? I'll tell you right now, passwords, license plates, names, IDs, they all have order. Okay? They all have order to them. AB is different than BA. So just take that into consideration. A password consists of 2 letters followed by 5 digits. So I need to pick a letter. I need to pick a letter. I need a digit. I need another digit. I need a 3rd digit. I need a 4th digit. I need a 5th digit. Where are they coming from? Well, for letters, we assume there are 26 letters. We're not going to distinguish between upper and lower case. Digits, there are 10 digits, right? 0 through 9. So 26 letters, 10 digits in any math problem you get. Start picking. I picked the first letter, 26 choices. Can I put it back? Yes, I can, because it doesn't say they have to be different letters. I can put it back, meaning you know some people like to make their passwords 1111, right? Nothing but 1. Sometimes you can get away with it. Some websites don't allow it. But anyway, since we never said anything about the letters having to be different or the numbers different, that is not what we mean by different passwords. We can put something back, so it's 26 times 26. We get to the digits, there's 10 digits, we can put it back, so the number is going to stay the same. Okay? So if you multiply all of this together here, that's going to be the answer, because again, we always assume a password has order to it, and if we have order, we're not dividing. And each one of these different groups, again, has order to it. Number 9 is a little bit different here, so pay attention, because this is typically a problem that is seen on a final exam. Okay, well, not this one. Okay, not this one, sorry. All right, this is the next one. I'm jumping ahead of myself. This password consists of 2 letters followed by 5 digits. So, I need a letter, I need a letter, I need a digit 1, a digit 2, a digit 3, a digit 4, and a digit 5. Where are they coming from? 26 letters, 10 digits, right? Messed up there, 10 digits, right? I'm following my routine. I start picking, I pick a letter, 26. Step 3, you ask, can you put it back? Nah, can't put it back. It says letters and numbers cannot be repeated. I can't repeat a letter, I can't repeat a number. Once it's used, it is gone, so I know my number goes down. I go to the digits, there are 10 digits. Likewise, I can't put it back, so my number starts going down. So once again, I have order here. Step 4, there's order. Because it's a password, since I have order, I'm not dividing, so do the product of all these numbers here. That would be your answer. It's going to be pretty large. Now here's 10. This one's a little bit different. My password's going to have, again, you stop the video, okay? Because I'm just trying to save time here. You stop the video and read the problem, all right? And then start the video again. So, again, I'm picking a password. That's what I need to do. But then sometimes there's a special condition in a problem, so things are a little bit different. Now, as I read through this, first letter has to be an A or a C. So, you know what? That first letter here is going to be A or C. You got to take that into consideration. Where are they coming from? Well, my letters are coming from 26 letters. My digits are coming from 10 digits. Now, this is a little bit different here, okay? But again, I laid the foundation in general what you have to think about, but there are always more complex problems. Here's one that's more complex. Again, the first letter has to be an A or C. I'm assuming it's coming from the same group here, okay? 26 letters, but it's got to be an A or C. When I go to pick the first letter, how many choices I have? I have 2 choices, A or C. That's all I have. If it had to be an A, there'd be 1 choice. But when I choose the first letter, it has to be A or C. I only have 2 options. Now the thing is, I picked 1 letter. I can't put it back. It tells me no repetition of letters. I didn't pick 2 letters. I picked 1. It's an A or a C. So when I go to pick the second letter, there's still 25, not 24. A lot of students will put 24 because they think once you pick one of the 2 letters, they're both gone. No. If I picked an A, I can still pick C for second. It doesn't say C can't be second. The only condition is A or C is first. So I picked the first one. There's 25 letters left. Wait, oh, I left this out. The first digit can't be 0. So this is special here too. That first digit can't be 0. If the first digit can't be 0, I have 9 choices. Right? There are 10 choices in the box, but I can't include the 0 right now. Now, whatever I do, when I pick that digit, the box now has 9 because there's 1 less digit. I can't put things back. 9, 8, 7, 6, 5. But again, you can kind of see that I laid it out. Now, I did overlook that My first digit could not be 0, so maybe I should have put not 0 right here instead, okay? Because again, I'm laying out what I need to do, and I did overlook that, but this is not edited. I had to pick an A or C, second letter. Pick something that's not a 0. Second digit, third digit, fourth, fifth, right? When I go to pick A or C, two choices. When I pick the second one, I have to realize that I only used one letter, there's 25 left. Go pick a digit, not 0, there are 9 choices. Go to pick the second digit, made a mistake here. There are still 9 here, right? Why? Because there were 10, there was 1 used here, there's still 9. That is a very common mistake here. So it's 9 times 9 times 8 times 7 times 6. There's order. When you do all this multiplication here, you have your answer, okay? So be careful. A lot of times students get used to going down. Ask yourself what's left in the box, right? Moving on to number 11. I'm a teacher. I'm going on a swamp trip. I can take only 3 of my 10 students. How many ways can I select the 3 students? What do I need to do? I need to pick a student. I need to pick a student. I need to pick a student, right? Where are they coming from? They're coming from 10 students. Start picking. 10. Can't put them back. Think why? So the numbers are going down, right? 10, 9, 8. Do I care about the order? Well, if I pick you first, you're going on a field trip. If I pick you second, you're going on a field trip. Didn't say anything different. I don't care about order. So I divide by 3, 2, 1 because I picked 3 things, right? Moving on to number 12. Again, stop the video, read the problem. Going on a field trip, same thing. 3 students out of 10. But now, first student feeds the alligator. Second student feeds the snapping turtle. Third student feeds the conga wheel, which is actually a 2-toed amphibian in Louisiana. How many ways can I pick my 3 students? Well, now, when you pick first, you're feeding the alligator. When you get picked second, the snapping turtle. Pick third, the conga eel. Where are they coming from? 10 students. Start picking 10, 9, 8 because I can't put them back. Once I select, does the order make a difference? Well, if you're first, you're alligator. Second, you're snapping turtle. That's a difference. So I am done. When there is order, you don't divide. So whatever that is, that's your answer. Okay? No order, that's when you're dividing, correct? So notice the difference between these 2 problems. Similar, but the first, you didn't care when you got picked. You divided out. When you got picked, made a difference. No division. I'm dreaming about being back at the fair. Yeah, right. Suppose I can order a king cake with 2 choices of each of the following. So now I have 2 choices of each of the following. 6 different doughs, 5 different fillings, and 3 different types of icing. How many possible king cakes are there? Each choice is different. Make sure I put that in there. So, what am I doing now? I'm going to pick 2 doughs. I'm going to pick 2 fillings. I'm going to pick 2 icings. Right? Order king cake, 2 choices of each of the following. 2 doughs, 5 fillings, and 2 fillings, 2 icings, right? I have 6 different doughs. I have 5 different fillings, and I have 3 types of icings. Since I have to make different choices, 6 times 5, 5 times 4, 3 times 2, right? Now, I get 6 times 5. I'm going to kind of show something here. It's always multiplication division, okay? There's my numbers, okay? Because step 4 is, do I have order here? Well, if you think about this problem, I would assume there's no order in which one. If I tell you I want wheat and then white dough, that's no different than white and wheat, right? Or apple and cherry, no different than cherry and apple. So there's no order in each one of these groups, right? And in each one of these groups, I'm picking two things. So in each one of these groups, I have to divide by 2 factorial. So 6 times 5 times 5 times 4 times 3 times 2 divided by 2 times 2 times 2. Just do your math. It's 8 in the denominator. 2 times 1 times. It's always multiplication. So multiply across the top, multiply across the bottom, do your division. Last problem here. This is the one that's a little crazy now. All right? And we'll do this in another 30 minutes. How do you like that? To communicate with other judges at the fair next year, I came up with an idea of having a signal form from 3 flags, 2 blue flags, and 3 yellow flags. These are going to be raised up on a pole. How many possible signals are there? Okay? So, what's going to happen? I need to build a signal. There's a total of 3, 4, 5, 6, 7, 8 flags, right? So, I'm going to be picking what? Well, should have done that. Well, I'm going to be choosing 1, 2, 3, 4, 5, 6, 7, 8, right? I'm going to have to order these flags, correct? I'm going to raise these flags up on a flagpole, and I'm going to be ordering. There is 8 flags, right? Okay? Now, right now, when I go to pick them, now here's the thing. I am considering as a single group. Why? I didn't say the red one was first, second, third, or fourth. I'm picking a flag. I'm picking a flag, a flag, a flag, a flag, a flag, a flag, and another flag. There's no distinguishing between the red, blue, and yellow when I pick. Do you understand that? Because if I tell you red's first, then that needs to be stated in the problem. I could have a yellow flag first or red flag second, right? Or red flag last. So right now, I just want to look at this as 8 flags. Again, there's always special cases. So start picking your flags. You can't put them back. 8, 7, 6, 5, 4, 3, 2, 1, right? 8 factorial. Now let me go down just a little bit more so I can show you. Now, here's my product. If all the flags were different, I would be done. But you got to kind of think about things. The 3 flags that are red, I can't really distinguish between them. So no matter where they show up, it doesn't matter the order in which the red ones were picked in, right? The first red, the second red is no different than the second red flag and the first red flag. They don't have numbers on them, so they're indistinguishable. So I don't care about the order of the 3 red flags. I don't care about the order of the 2 blue flags. I don't care about the order of the 3 yellow flags. All right? So step 4 is all about order. But the difficulty with this one here is students tend to think of the flags being different when I go through the selection process. When I'm selecting, I didn't say red first, blue second, yellow last. Then I could kind of think of them as being separate groups. But when I actually am picking, I'm only picking from 8 flags. That's what I'm picking from. Okay? 8 flags. I pick them, but then I have to realize, you know what? I can't distinguish between the reds. I can't distinguish between the blues or the yellows. Do your math. Okay? And we are done. Thank you.